Absolute value functions are a little tricky because of the sign, but don't worry, we are going to go over them. Oops, sorry, I'm just going to erase that. And let's start. Okay. So this function we have here is a very basic absolute value function. It's y equals to the absolute value of x, and x could be any number. X could be 1, x could be 10, x could be -7, it could be any number. Remember, whatever you put in the absolute value comes out, if you put a negative absolute number in the absolute value sign, it comes out as positive. If you put a positive number, it comes out as positive. So if you put in y equals absolute value of -7, how you will graph it is y equals 7. If you put in y equals absolute value of 7, it will come out as y equals just 7. So the negative goes to positive, and the positive stays as positive. You can remember this small tip, you will be good to go. And you will be needing this to graph here. So, if you want to look at the points here, let's look at the coordinates here. See what we see. We have this point, we have this point, this point. Okay. So these are, you could say x equals 1, x equals 2, x equals 3, and then you go on, and then y equals 1, y equals 2, y equals 3. We don't really see an intercept because you see there is nothing after this. You just see a slope. You don't see any intercept. That happens. But we will be seeing intercept when we're looking at transformations of absolute value functions. So let me just go over some basic transformations with you guys. So if you have a function y equals absolute value of x, and if it's multiplied by something outside, let's say it's multiplied by 2, so that would be 2 times the absolute value of y. Then that means you're going to just distribute that value, that number, to whatever you have inside the absolute value sign. But it also means if you want to look at it from a graphical point of view, it means that you will be expanding your graph 2 times as much as before. And if you multiply by 1/2 instead of 2, you will be shrinking your graph half times as much as before. Now, next thing, that was the first transformation. The second transformation would be shifting up and down. So if you have something like this, y equals the absolute value of x plus 2. So that means here you did not have any shift. So your y was 0 at all at this time. And what you're going to be doing, you're going to be moving. You're going to be doing a shift. So the shift will be something like this. I'm going to draw that. First, your graph look like this. Now, when you're going to be doing a shift, your shift will look like this. So it's 2 up. You move your graph 2 up. If you move it 2 down, your graph will look like this. That's 2 down. That's the way. Next thing, next transformation will be, next transformation will be something like this. If you're going to be flipping your graph, so when you flip your graph, what happens is the sign in front of the whole equation, the entire equation changes. So what you don't have to put a parentheses, but if you feel necessary, you can definitely do that. If you feel like you need to put it, but usually there is no parentheses. The negative sign just goes in the front. But let's see. So what it's a lot similar to the transformation we did in number 1, because all we're doing is distributing that negative sign inside the parentheses to the 2 and the actual value of x. So that's where we are. Next we'll be doing this. So what happened is you flip the graph. The graph is flipped. So let me show you how it looks like on a graph. You had this graph. It was y equals actual value x plus 2. Now you want to flip it. So what you'll do is you'll flip it about the x-axis. So what happened essentially, it's the same graph. All you're doing is a reflection. You could also call it a reflection if you like a transformation. But it is really all that happened is all the values that you put in now will be negated when you put it into this equation. So if you put in the absolute value of 1 and plus 2, that will give you 3. But if you put in here the absolute value of 1 plus 2, and then you have to distribute that by the negative outside, that will give you a negative 3. So like I said, if you want to write out a table and then do the graph, that's easier. If you just know the transformation, the back of your head, you can do that. That's also fast and convenient. But if you like to see it visually, I suggest that is what you do. Now let's move on to piecewise functions. Piecewise functions are basically, they are a little difficult for some students. I know, because it's basically not a system of equations that's given to you. It's a system of different functions that you're given, and you have to plot them in different ways. And they don't look like a continuous straight line. They're piecewise, which means they're broken up into little pieces. But as a whole, they make up one big function. So let's go over a piecewise function. I'm going to draw a graph first. Okay, now I'm going to draw the function. So here we are with our piecewise function. So you see there are a total of 3 pieces on this graph. We have piece A, piece B, piece C. Now looking at this, some people might not know what is going on, what does the circles mean, what does the shaded circles mean, why are some shaded, why are some empty, not shaded. But we're going to look at it, and we're going to figure it out step by step. So let's look at function a first. That's a piece of the entire function. Let's call the entire function f of x. Okay. Now let's look at function a, which is the piece. Now you see there is a shaded at 5 and it's empty at 1. So what does the shaded mean? The shaded means that the function includes that value, which is what? Negative 5, 6. That's included in the function. The empty one is negative 1, 6, which is not included in the function. Not included. And then let's look at b. What is that telling you? That's the shaded part right here is the value 9, negative 7. That's included in the function. The empty part here is the value negative 1, negative 7. That's not included in the function because that's empty right here. Let's look at function c. You have negative 9, negative 7, which is not included in the function. Then you have negative 5, negative 7, which is included in the function. So those are our coordinates we have. Now we can use these coordinates to write our function from the graph. So let's do function a first. What is included? Function a goes from negative 5 to negative 1 right here. So that will be negative 5. It's included and is equal to included. Remember, a shaded means included and equal to, and a non-shaded just means less than or greater than, but not included. Now, negative 5, I'm just going to erase this. Negative 5 is included, negative 5 is included, but it's not equal to, so negative 5x. What this means is negative 5 is less than negative 5 because it's not going beyond negative 5 over here, but it's definitely greater than negative 1. Yes. Now let's move on to the next one. Negative 1 and 9. So this one is function b. Now you look at negative 1, it's x is greater than negative 1, right? But it's not equal to because it's not shaded over here. But if you look at here at 9, it is shaded and it's also less than. So it's less than and equal to. And that makes sense right here. And for this one, I just want to say again, here x is less than negative 1 for function a. Because negative 1, negative 2, negative 3, all of this, it's definitely less. As you get more negative, you get less than 1, negative 1 or 0. Now let's look at the last one, which is your function PC. In C, it's from negative 9. X is greater than negative 9. Because you see, x is in that way. It's not becoming more negative. It's going this way, not this way. X is greater than negative 9, and it's shaded right over here again at negative 5. So it's less than and it's equal to -5. So those are our three intervals. And the first thing that you might and you should actually do, which I suggest, is to find the intervals wherever you see a piece by piece function, which because then that will help you move forward. That will help you move forward. And then we just put the y values 9. Actually, no, you put the not 9 here. Now we're going to be moving on to the last topic for this video, which is inequalities. So how do you graph inequalities? How do you graph inequalities? Graphing inequalities, I'm going to give it to simple, in a simple way. That will be, let's start with an inequality. Y equals 4x plus 3. So now that's an equation. Now I'm going to change it to an inequality. Y is less than and equal to 4x plus 3. Okay? So that's that. Now one thing that you can do is start with a graph. Best thing to do is start with a graph or a table. So what will you do? Y equals 4x plus 3. For this purpose, we're going to use equal, but we're going to change it later to the less than and equal to. But we'll do that later. Now, just for our easy purposes, we're going to do this. Make clear. Okay, so what happened with x? Let's do -1, 0, and 1. So when x is -1, what is y? When x is 0, what is y? When x is 1, what is y? 4 times -1 is -4, plus 3 is -1. 4 times 0 is 0, plus 3 is 3. 4 times 1 is 1, plus 3 is 7. Okay? Okay. So now look what we can do next. Let's just put our values in the table. -1, 1, 0, 3, and 1, 7. So what does this inequality actually means? It means that for any value of x that you put in, the y that you get is less than or equal to. Less than or equal to. Now let's start graphing it. Let's do 5, 7, 2, 0, 3, -1, 1, and then 1, 7. We're going to do a shaded line right here. Okay. So now let's look at this line for a while. It's not a shaded line, it's a broken line, it's not a solid line. And the one more thing I want to tell you that you must know is that When you have an equal to, less than or equal to, greater than or equal to, and you have equal to sign, your line should be broken. When you just have greater than or equal to, your line should be solid. So here we have an equal to along with the less than, so that's why our line is broken. Now, we plotted everything, we plotted what we found. Now the only thing left is to show how all the y's that we have from this graph that we get by putting in any x, the y's are either equal to x or they're less than x. They're less than x. So what we're going to do, we're going to shade below. We're going to shade below.